Alright, today we're going to be looking at exponential functions. You're going to be able to graph them. You're also going to ID the data that has exponential behaviors. So let's look at this one. It says functions that the exponent is a variable. So it'll look like y equals 2 raised to the x power, so the variable is an exponent. Then we are going to look at our xy table, and we're going to make x is negative 2, negative 1, 0, 1, 2 every time, and then put in those numbers in for x. So in doing so, we will have a problem that will look like this. And now you're going to put all these in there, and you're going to get your y values. So in order to put those in there, you got to go 2 raised to the negative 2, 2 to the negative 1, 2 to the 0, and so on. And your results will be as follows. Now graphing these things, that just means negative 2 up a little bit, negative 1 up a half, 0 up 1, 1 up 2, 2 up 4, and 3 up 8. Now since there is a possibility of having points in between and beyond, that's what we're going to do. We're going to draw a line that would represent all those points, and then beyond with an arrow. It should also be noted that this bottom left section of the graph will approach the x-axis but never cross over and never go back up. So it'll basically become a near flat line at that point. We also have a y-intercept at where is that? 0, 1. So the y-intercept is at 0, 1. So if we had to write it down as a solution set, the y-intercept is 1. All right, this one here, let's put in the negative 2, negative 1, 0, 1, 2. And in this section right here, I'm going to actually white this part out and put in there the 3 raised to the x minus 2. So in this particular problem, it's going to be 3 raised to the negative 2 minus 2, 3 to the negative 1 minus 2, 3 to the 0 minus 2, 3 to the first minus 2, and 3 to the second minus 2, and then our y values. Now our y values will be negative 1.8 repeating, or negative 1 and 8/9, negative 1.6 repeating, negative 1, 1, 7. Now if we did 3, it would have been like 25, so we're not going to bother with that one right now. So negative 2 down almost 2, but not quite. Negative 1 down just a little beyond half, 0, negative 1, 1, positive 1, and 2, 7. Again, it will be a line that approaches, it flattens out right here, but never crosses and never actually touches, even though it might appear that it does. Now this next one, as you can see, we have a table already done with the negative 2, negative 1, 0, 1, 2. I put in the negative 2, negative 1, 0, 1, 2 in for the x value, and the results are as follows. Now in graphing it, negative 2, 9 starts off high, negative 1 up 3, 0, 1, 1 up a third, and 2 up just a touch, and it flattened lines in the other direction. Now as far as the next part, which one shows exponential behavior? That is, if the x's increase by a constant plus, the y's will increase with a constant multiplication or division. Now it could be a decrease if it's dividing. So is this one exponential? Well, the x's do increase by 1, and the y's, alright, and then the y values seem to be increasing by 3. And that would be an increase of plus 3. So it's a no, because as x's increase by a plus 1, the y's increase by a plus 3, and since it's a plus instead of a multiplication, that is not exponential, more linear actually. And this one here, if we add by 1, okay, they increase by 1, these will increase, and you might have to take the second and divide by the first, and you get 2.5. And if you multiply by 2.5, you get 10, of course. Multiply by 2.5, you get 25, and if you multiply again by 2.5, you get 62.5. So that one is a yes, and the reason for that, as x's increase by +1, the y's increase by a multiplication of 2.5. And there you go.